Welcome to The Explainer. Today, we're going to talk about a piece of technology that millions of us, seriously, trust with our lives every single day, but we almost never actually see it.
I mean, really think about it for a second. We step into this metal box and just trust it completely. But what's really going on behind the scenes to make sure that journey is perfectly smooth and, more importantly, totally safe? Well, it's definitely not magic. It's an incredible marvel of precision engineering, hidden just out of sight.
So let's meet the unsung hero of your daily commute, the elevator guide rail. Yep, we're talking about the elevator's silent spine. These steel tracks are the absolute foundation of every single safe and comfortable ride you take. All right, so what do these things actually do? Well, according to the experts at Novinpooyalift, these are way more than just simple tracks. They have three absolutely vital, you could even say life-saving jobs.
Okay, so let's get specific. An elevator guide rail is basically a T-shaped steel beam. They're installed vertically, running up the entire elevator shaft, and they create this super precise track for both the elevator car and its counterweight. The whole point is to create one single, perfectly straight and incredibly rigid pathway from the very bottom of the building to the very top.
So here are the three core functions: flawless guidance, providing an emergency braking surface, and ensuring structural stability. Now, what's really interesting here is that these jobs don't work in isolation. It's how they all function together that guarantees both your safety and a smooth performance.
First up, flawless guidance. This is exactly what it sounds like. The rails keep the elevator car and its counterweight perfectly aligned. That's what prevents any sway or vibration. This precision is literally the difference between a smooth, comfortable ride and one of those shaky, unsettling ones that makes you grab the handrail. Now for job number 2, and this one is huge. Emergency braking. This is the worst-case scenario we all think about, right? What if the cables fail? Well, the car's safety system, which is sometimes called the parachute, literally clamps down onto these guide rails with immense force, bringing the whole car to a secure stop. The rails have to be strong enough to withstand that. It's an absolutely critical safety component. And function 3 is stability. This is pretty amazing when you think about it. Tall buildings actually sway in the wind. The guide rails absorb those side-to-side forces, and even forces from minor seismic events, to keep the car perfectly stable. This shows you the rail isn't just a passive track, it's an active defender, constantly protecting the car from these powerful external forces.
So how on earth are these crucial components made? Well, it turns out not all guide rails are created equal. It really starts with two main manufacturing methods.
The first method is called cold drawn. You take a hot-rolled steel profile and you literally pull it through a die at room temperature to shape it. This is the most common method, and it's ideal for elevators with low to medium speeds, like the ones you'd find in a lot of residential or low-rise commercial buildings. Method 2 is called machined. Here, you take that same hot-rolled steel profile, but instead of pulling it, you use machines to precision mill or grind down its critical surfaces. The whole goal is to get superior smoothness and accuracy. As you can imagine, this is a much more intensive and expensive process, and it's reserved for elevators where absolute precision is completely non-negotiable. And this table just lays it all out so clearly. You can see the trade-offs. Cold-drawn rails are cost-effective, the workhorse for standard use. But when you look at precision, machined rails are on another level. We're talking hundreds of a millimeter. That's why they're a technical necessity for high-speed, high-performance elevators, the kind that travel at 10 meters per second or even more. Okay, so how do engineers decide which type to use? Well, it all comes down to the elevator-specific job. And as this chart shows, it really comes down to one critical factor: speed. Think about it. The faster an elevator travels, the more any tiny, tiny imperfection in that rail is going to translate into a noticeable vibration inside the car. That's why those super high speeds demand the incredible, exceptional precision of a machined rail. There's just no way around it. And you can see a really clear progression here in the real world. Now those codes, like T45 or T127, they're not random. That number actually tells you the width of the rail's guiding surface in millimeters. So, as we go from a simple home lift to a massive skyscraper, the rails have to get wider, more robust, and require the precision of machining to handle those immense speeds and loads. But here's the thing, you can have the world's best, most perfectly made guide rail, and it's completely useless if it's not installed with absolute perfection. The whole system starts with these brackets. They're the critical link that anchors the rails to the building structure.
And their spacing isn't random, it's very carefully calculated to prevent any bending or vibration. Honestly, these brackets are just as important as the rails themselves.
And this is where it gets really high-tech. Technicians use advanced laser alignment systems to position the rails with tolerances of just fractions of a millimeter over the entire height of the building. This painstaking process is what ensures the path is perfectly vertical and parallel, which, as we've learned, is absolutely essential for high-speed travel.
So, the next time you step into an elevator, I guarantee you're going to have a whole new appreciation for the hidden engineering that's hard at work all around you.
I really love this quote. The guide rails are the hidden vertebral column of any ideal elevator system. It just perfectly captures their central, supportive, and absolutely vital role. It's the perfect analogy.
So what seems like just a simple track is actually the result of this incredible journey of precision, from the choice of steel to the manufacturing method, all the way to that laser-guided installation. It's a highly engineered system designed for one purpose: your safety and comfort. So now that you know the engineering behind your ride, it kind of makes you wonder, right? What other hidden marvels are all around us that we just take for granted every day? It's definitely something to think about on your next ride up. That's all for this explainer. Thanks for joining us.